Hello everyone, I'm Shudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narla Institute of Technology. Today I'm going to talk about topic of switchgear and protection subject. So this subject, switchgear and protection, is designed for the student of Diploma Electrical Engineering, third year, fifth semester, Electrical Engineering. The lesson plan is here. In this lesson plan, I'm going to cover three topics, Unit 1, Unit 2 and Unit 3, these three units. So within this three unit, my today's topic of discussion is the first one is the pickup current. I will talk about what is the pickup current. Then the second topic is the current setting. The third one is the plug setting multiplier, or you can say the PSM. Next one is the time setting multiplier. And the last one is the numerical. Numerical means the related numerical. So let's start talk about the topic. The first one is the pickup current. So first, if you think that what do you mean by pickup current, then let me explain the pickup current. It is very easy to understand what is the pickup current. It is minimum current. Okay, minimum current in the relay coil at which the relay start operate. Okay, so some topic, or you can say some term you have to remember for this pickup current. The first one is it is a minimum current in the relay coil, okay, at which the relay start operates. So this current, this minimum current, is called the pickup current. So long as the current in the relay is less than the pickup value, the relay does not operate, and breaker controlled by it remains in the closed position. However, when the relay coil current is equal to or greater than the pickup value, the relay operates to energize the trip coil when opens the circuit breaker. So in this way, the pickup current normally operates. Next, we will try to understand that what is the current setting. So it is often desirable to adjust the pickup current. We already know what is the pickup current from the last slide. This is the pickup current, the minimum current. And now the current setting means it is often desirable to adjust the pickup current to any required value. Okay, so as per the requirement, we need to adjust the pickup current to any required value. This is known as current setting and is usually achieved by the use of tapping on the relay operating coil. So the taps are brought out to a plug bridge as shown in the figure. So if you follow, you can find in this figure two relay operating coil. So look here, the values are given 50, 75, 100, 125, 150, 175 and 200. So bridge as shown in the figure, the plug bridge permits to alter the number of the turns on the relay coil. Okay, this changes the torque on the disc. You know that inside the relay there are the jigs. So this changes the torque on the disc and hence the time of operation of the relay. Now the values assigned to each tap are expressed in terms of percentage full load rating of city with which the relay is associated and presents the value above which the disc commences to rotate and finally closes the trip coil. So in this way, we set basically the current setting. So here the current setting values is there. So I already discussed this topic, that the value assigned to each tap are expressed in the terms of percentage full load rating of the city. So here the and which the relay is associated and the present the value above which the disc commences to rotate and finally closes the trip coil. Okay, now let me talk about the pickup current equation. We can develop some equation using this pickup current. So what is the pickup current? Look here. Uh, pickup current is equals to the rated secondary current of city. Rated secondary current of city into current setting. So multiplying the value of the rated secondary current of city and the current setting, we get the pickup current value. So for example, we can consider that suppose that an overcurrent relay having current setting of 125%. So what we consider first? Suppose that an overcurrent relay having current setting of 125%, and which is connected to a supply circuit through a current transformer of, so current transformer is 400 by 5. The rated secondary current of city, what is the rated secondary current of city? This is 5 because 400 is the primary and 505 is the secondary current, rated secondary current. Therefore, the pickup value will be 25%, okay, more than 5 ampere. That is 5 into 100, 5 into 1.25 equals to 6.25 ampere. It means that with above current setting, the relay will actually operate for a relay coil current equal to or greater than 6.25 ampere. So this is the explanation about the pickup current. So what is actually the gist? Look here. For an example, suppose an overcurrent relay having the current setting 125%. No problem with this. Then we consider a current transformer that is 400 by 5. So the secondary value is 5 ampere. The rated secondary current of the city is 5 ampere. Therefore, the pickup value will be 25% more than 5 ampere. No problem because 125% we consider, so it should be 25% more. So 25% more means 5 into 1.25. That means if we multiply with current setting and the secondary current, that should be 5 into 1.25. Rated secondary current is 5 and the value current setting is 1.25. So finally we are getting the value 6.25 ampere. It means that with above current setting, the relay will actually operate for a relay coil current equal to or greater than 6.25 ampere. Okay, so in this way we can find the pickup current using the rated, this one, the rated secondary current of city and the current setting. Now the current plug setting usually settings usually range from 50% to 200% in steps of 25% for overcurrent relays and 10% to 70% in steps of 10% for earth leakage relays. The desired current setting is obtained by inserting a plug between the jaws of a bridge type socket at the tap value required. So here we can say that the current plug setting usually range from 50% to 200% in steps of 25% over the relay and 10% to 70% in steps of 10% of the earth leakage relay. This desired current setting is obtained is inserting a plug between the jaws of the bridge type socket or the tap value required. So in this way we can also explain the pickup current. So we have to remember all these steps. Now the plug setting multiplier. Let's talk about the plug setting multiplier. That what is the plug setting multiplier and how we can measure the value or we can develop the equation of a plug setting multiplier. Let me talk about that. So first try to understand what is the PSM or plug setting multiplier. Look, the PSM or plug setting multiplier is basically a ratio of fault current in relay coil to the pickup current. Okay, so I think you already know about that. What is the ratio of the fault current in the relay coil and what is the pickup current? I already discussed about this, that fault current in the relay coil and about the pickup current. So PSM is basically equals to fault current in the relay coil. This one, the fault current in the relay coil, and the pickup current. Okay, so that is equals to fault current in the relay coil, and what is pickup current? We already know, the rated secondary current of CT into current setting. So this one we already proved with the mathematics in the last problem. So PSM, or you can say the pickup plug setting multiplier, is fault current in the relay coil divided by pickup current, and we know that the pickup current is the rated secondary current of CT into the current setting. Now here, for an example, suppose that a relay is connected to a 400 by 5 current transformer and set at 150% with a primary fault current of 2400 ampere. The plug setting multiplier can be calculated as under. So pickup value equals to rated secondary current of CT into current setting. We also know this, we already proved this one in the previous slide, that what is pickup current, rated secondary current of the CT into the current setting. Now what is the rated secondary current? That is 5. So just write here 5. And what is 1.5? It is current transformer is set at 150%. That means 1.5. So that is equals to 7.5. So if we multiply these two, the pickup value will be 7.5 ampere. Now the fault current in the relay is 2400. The primary fault current 2400 into 5 divided by 400. That means the fault current is 30 ampere. So the PSM will be equals to 30 divided by 4. 30 divided by 7.5. That equals to 4. So if we now use this, the equation 30 by 7.5, that should be equals to 4. So in this way we can find the PSM. So to find the PSM, first we have to find the fault current in the relay coil. So after getting the fault current in the relay coil, we have to find the value of the pickup value. Then we can easily find using the equation of the PSM. And for this problem here, the PSM value is 30 divided by 7.5. That is equals to 4 ampere. Now let me talk about the time setting multiplier. Look, so what is the time setting multiplier? So after the clock setting multiplier, the time setting multiplier, a relay is generally provided with control to adjust the time of operation. This adjustment is known as time setting multiplier. Look, try to understand very carefully. The relay is generally provided with control to adjust the time of operation. Okay, this adjustment is known as time setting multiplier. Fine. So the adjustment which is doing that adjustment is basically known as the time setting multiplier. Now for the time setting multiplier, if we consider the time setting dial is calibrated from 0 to 1. So as per the figure, if you follow the figure, you can find that in this figure we consider it is 0 to 1. So the time setting dial is calibrated from 0 to 1 in steps of 0.05 seconds. So the steps, total steps is divided 0.05, 0.05, again 0.05. So all the steps are 0.05 as per the below figure, this figure. These figures are multipliers to be used to convert the time derived from time slash PSM curve into the actual operating time. Okay, so Thus, if the time setting is 0.1, so if the time setting is 0.1 and the time obtained from the time or PSM card is 3 seconds, then actually relay operating time is 3 into 0.1, that means 0.3 second. So in this way we can find the value of the actual relay operating time. So 3-second delay, and you have to find the time setting. So multiplying the delay and the time setting, we can easily find the actual relay operating time. Now, and we have to take the help from the time PSM curve. So from the time PSM curve, where the PSM along the x-axis and the operating time along the y-axis. So from that curve, we can easily take some value, take the value that which is the value which is called the value of the time PSM curve value. So with the help of that value from the time PSM curve and the time setting, that what is the setting of the times, so we can easily find the actual relay operating time. Now, for instance, in an induction relay, the time of operation is controlled by adjusting the amount of travel of the disk from its reset position to the pickup position. Now, this is actually achieved by the adjustment of the position of a movable backstop, which controls the travel of the disk and thereby varies the time in which the relay will close its contacts for given values of fault current. A so-called time dial with the evenly divided scale provides this adjustment. So the actual time of operation is calculated by multiplying the time setting multiplier with the time obtained from the time PSM curve of the relay. So in this way we can find the value of the actual time. Here, if you follow, you will find this is the time PSM curve. Determine the time of operation of 5 ampere 3-second overcurrent relay having a current setting of 125% and a time setting multiplier of 0.6 connected to supply circuit through a 400 by 5 CT or current transformer when the circuit carries a fault current of 4000 ampere. Use the curve shown in the below figure. So with the help of this curve, we already solved the problem in the previous slide. So for this case, it's a determine of time operation, and here the all values are given. Now, from the curve, from the previous point, we know that to solve any problem of this type, any type of problem in engineering or in any type a problem we can solve with the given data and the value. So here in the problem it is given that the rated secondary current of city. So what is the value of the rated secondary current of city, which is given in the problem? The value is 5 ampere. And the pickup current we know that it is 125%, that means 5 into 1.25. So the value will be 6.25. Same problem we solve in this presentation. Now the fault current in the relay coil will be equals to 4000, that is the fault current into 5 divided by 400. So the value will be, fault current value will be 50 ampere. Now plug setting multiplier, we know the equation of plug setting multiplier, so that should be the fault current in the relay. So 50 divided by 6.25, that means the pickup current. So 50 divided by 6.25, so the value will be 8. So in this way we can find the value of this plug setting multiplier from the given problem corresponding to the plug setting multiplier of 8. So here it is 8. The time of operation is 3.5 seconds. So here the time of operation is 3.5 seconds. So look, if we consider this value from the plug setting multiplier of 8, the time of operation is 3. So the corresponding value, it will be 3.5 seconds. So actual relay operating time will be 3.5 into time setting. So here the time setting, the value is 3.5 and the time setting is 0.6. Okay, so it is 0.6. So the total value of the actual relay operating will be 2.1 seconds. So in this way, we can solve this type of problem very easily. And it's a nice way to solve the problem of relay. And you can apply this concept in your real life experience also. You can apply this problem in your future life also. So to make this PowerPoint presentation, we can take help from this book. The name of the book is The Principle of Power System by BK Mehta and Rohit Mehta. It's a very good book for the students of diploma and also for BTech. Thank you everyone for your patience. Thank you everybody. If you have any queries, any clarification, if you need, you can contact with me anytime. Thank you all. Thank you very much.